I want to discuss how you compute the variance and standard deviation for a number of observations. This is quite common in finance. For example, suppose we have 4 years of returns here, 10%, 4%, minus 3%, and 8%, and we want to figure out the variance. What do we mean by that? We want to figure out how spread out these observations are around their average value. So the first thing we want to do is we want to compute their average value. So how do we do that? The average is going to be equal to summing up from t equals 1 to n RT, which is the observation or the return in period t, divided by the number of observations. So if we wanted to do that, we have 10% plus 4% plus a negative 3% plus 8%, and that's all going to be divided by 4. So let's see what we get here. We have 10 plus 4 plus negative 3 plus 8, which is 19, divided by 4, so we get 4.75%. All right, so we know that's the average of these. Now, how spread out are these numbers around this average? So what we want to do is we want to compute the deviation from the mean. So let me do that first. In fact, tell you what, let me give you the formula for variance. The formula for variance is the following. The variance is going to be equal to, we're going to sum up from t equals 1 to n RT, and let's call this average R bar, minus R bar squared, and then we're going to divide the whole thing by n minus 1. And instead of dividing by n, we divide by n minus 1 because, as statisticians will tell us, we lose a degree of freedom. We lost a degree of freedom when we computed the average here. So you should divide by 3 instead of 4. Now, with a small number of observations here, that makes a difference. Of course, if you had 1,000 observations, whether you divided by 1,000 or 999 wouldn't make a huge difference in the computation. So the easiest way to do this is probably to set up a table. So up here we're going to have the deviation, and so we'll have 10 minus 4.75 for the first observation. The second one will be 4 minus 4.75. Okay, they're all the same average. Minus 3 minus 4.75. And 8 minus 4.75. So that's going to be the deviation. And we can work these out. This is going to be 5.25. This is going to be equal to negative 0.75. This is going to be equal to minus 7.75. And this is going to be equal to 3.25, I believe. Now, you'll notice that you have some positive numbers and some negative numbers. So if we just added those up, the positives and the negatives would cancel themselves out to some degree, and you wouldn't get quite as much information about how spread out you are around the average. So when we calculate the variance, we're going to square these terms. Then everything's going to become positive. Okay, so here we're going to have the deviation squared. So let's do that. 5.25. can hit the x to the squared key. So that's 27.5625. 5625, and then we have 0.75, okay, negative, and we can square that. See how we get a positive number? That's 0.5625. And then we have 7.75, negative, square it, 60.0625. And then 3.25 squared, 10.5625. We're going to add those up. So I'm going to add this plus this, 60.0625 plus 0.5625 plus 27.5625. And that's going to equal 98.75. Now this is the squared deviation, so let me put that in here. So this is going to be 98.75, and we're going to divide it by 4 minus 1, or 3. So we divide it by 3, and we get 32.99. Let's just round it off. 91. We'll round it off to 92. 32.92. The standard deviation is just going to be the square root of the variance. So it's going to be the square root of 32.92. So let's just hit the square root key, and we get a standard deviation of 5.74. So this gives us an idea of how spread out we are around the average. Oftentimes we'll use this in finance. We'll use the average return as a measure of what return we expect to get, perhaps an expected return, and we'll use the standard deviation as a measure of risk. How spread out are we? If we had a standard deviation of 0, that means there's no risk. And if you go back to these observations, you would get a standard deviation of 0 if all of these numbers were the same. If it were 10, 10, 10, and 10, that means that there's no risk. There's no spread around the average. You're always going to get 10. So if you do the calculation and you get a standard deviation or a variance of 0, you probably forgot to square the terms unless these are all the same numbers. So if you had these numbers and you got a 0 variance, it means you forgot to square them, and some of these negative numbers canceled out some of these positive numbers that turned out to be 0. That's why we squared the terms. So this is a good measure of risk, and we use it a lot in finance. It's a pretty straightforward calculation. All right, best way to do it, especially if you're taking an exam, is to set up a table like this. It's much easier to work across and to see what you're doing and to do the calculations. In another tutorial, I show you how to calculate standard deviation and variance when, instead of there being equal weights, for example, each year, you have a probability assigned. For example, different states of the world, a 30% chance of recession, a 50% chance of normal growth, and a 20% chance of inflation. And the calculations are quite similar, but instead of dividing by the number of observations, you weight each observation by the probability.